Okay, I'm just going to do some examples now. I'm just going to do the same examples that are in the book in chapter 18. So it talks about a relative theology along straight beach, the position of speedboat, and is modelled, and they've got the model down there. It says that I and j are the unit vectors perpendicular and parallel to the beach. So I is perpendicular to the beach. So if I just draw on a beach, I is perpendicular to the beach, and j is parallel to the beach. We're told that a boat is somewhere 6 meters out, so it's 6 in the I direction. We're also told that the position, to work out the position of that, it is 2t plus 2 in the I direction. For the j direction, we have got the position vector 12 minus t squared is how we work it out. So we can see that these coefficients must be equal for it, or this must equal 6. So we can create an equation. 6 equals 2t plus 2. Take away 2 from both sides. 4 equals 2t, so t equals 2. We can now use that to get the position of j. So I put 2 squared in. 2 squared is 4. 12 take away 4. So 12 take away 4 gives us 8 in the j direction. We can then create a diagram for that. So we've got 6i and 8j. We can now get the distance the boat is away by squaring using Pythagoras, which is 10 meters. 6 squared plus 8 squared, and then take the square root of it, gives us our 10 meters. Part 2 asks for a sketch going between 0 and 3. So time, and it's wanting the position. Remember, R stands for the position. So if I put 0 in, the position in the I direction, 2 nothings are nothing, so we just get 2 in the I direction. And we put nothing in there, we just get 12 take away nothing, which is positive 12. If we go for 1, 2 ones are 2, plus 2 gives me 4i, 1 squared is 1, 12 take away 1 is 11, so plus 11j. This table is given to you, but that just shows how you end up plotting it. So I'll just write down the other numbers now. We get 6i plus 8j, and for 3 we get 8i plus 3j. This can be plotted on the graph just like what's been shown to you in the book. Again, we're going to come along 2 up 12, along 4 up 11, along 6 up 8, along 8 up 3. Obviously it doesn't, I'm just completely changing where I put my dots, but I've not got an accurate drawing, so you would just then plot it the way it appears. Now part 3, find an expression for the velocity and the acceleration of the speedboat at t, and is the boat ever at rest. Now from before the previous videos, we should know that if we've got the position and we differentiate the position, we end up getting the velocity. If we've got the velocity and we differentiate the velocity, we get the acceleration, which means that the velocity will be the position differentiated. So if we differentiate in the I direction, we end up getting, with respect to t, then we end up getting 2, and if we differentiate in the j direction, we end up with minus 2t. So that ends up getting us the velocity. Now the acceleration, to work out the acceleration, we're going to differentiate again, so that disappears in the I direction, which means it ends up not accelerating in the I direction at all, but we end up with minus 2 in the j direction. So I actually just kept on these I and j within the answers. So therefore, because we end up, the velocity can never be 0, because it's going to always end up being the 2 that's got within there. Now the fourth question, for t equals 3, calculate the speed of the boat and the angle direction that motion makes with the beach. So this time we're looking for calculating the speed. So first of all, we'll need to use the velocity. And once we got the velocity, if we then find the magnitude of the velocity, then we'll end up getting the speed. So first of all, let's sub in t equals 3. So we end up with 2I take away 2 times by 3, which gives us 6j. And that'll be what the velocity is. Now we can draw a diagram of this, so we end up with 2 in the I direction and minus 6 in the j direction. 2 and 6. And that's the velocity kind of there, which means that we can work out the position of that. And we need to work out the angle that it's going at. Now, with the angle it's going at, it says the angle its direction of motion makes to the line of the beach. So if I take this as being the beach, going back up to this original bit, we're looking for this angle in here. And if we use alternate angle, it's going to be that angle in there. So we end up getting tan theta is equal to opposite over adjacent, which means that theta is equal to 18.4. And it then says, suggests by this model, this motion of the speedboat is unrealistic for a large t. So if we then took the velocity and worked out the magnitude of this, then we could end up, we would get 2 squared plus minus 2t all squared, and take the square root of it, which means that we end up with plus 4t squared. So you can see from here that with t always increasing, it means the speed is going to continuously increase. And there'll be a time when the boat wouldn't be able to do that anymore. Okay.